Michail Rybakov, and this project is about personal space and the city. As you walk the streets of your city, do you notice when people are too close? Do you care about who is close to you? Do you feel the borders of your personal space? Do you feel secure in a crowd, or is it overwhelming? In different parts of the city, the experience is different. At some places, people are almost always in your personal space. At others, it rarely happens. So, how can we visualize, measure, quantify this experience? The personal space is invisible, even though you feel very strongly when someone violates it. So, to visualize it, I use the Kinesphere as a proxy. The Kinesphere is the space of potential movement. How far can you reach? I used state-of-the-art pose detection models to draw the kinespheres around each person. We can choose to visualize only the overlap of the kinespheres, here in red. On this square, many of the people belong to a group, and so they share their personal space. People mostly avoid running into other people's personal space. But what happens if the architecture of the city forces them to run into each other? For example, through the narrow entrances to the metro stations, or because somebody left an e-scooter on the sidewalks. We can simulate this behavior in the browser. The colorful dots are pedestrians with circles around them signifying their personal space. They try to avoid each other and the obstacles that you can draw, but they can't always manage. And when they collide, a white trace is left behind. Over time, we can observe where the people mostly run into each other, where their narrow points lie. Together with the scientists of Sony Computer Science Lab in Rome, we ran simulations on different pedestrian densities. Will the rate at which people run into each other grow linearly with growing density? It turns out, no, there is an interesting curve. Up until the density of about 0.3 person per square meters, the rate of personal space violations, or in other words, Kinesphere infringements, grows slowly but linearly. Then it grows faster because people cannot easily avoid other people. And from 0.4 persons per square meter, it grows at a fast linear rate. So basically, between 0.3 and 0.4 persons per square meter, a state change happens from personal space to crowd space, from being able to avoid others to being part of the crowd. Every time the people in the simulation run into each other, they create a white trace. Over time, these traces accumulate and create a kind of a map. Now, when I say map, you might think of something like Google Maps, something bland and boring, but it doesn't have to be this way. To explore different map aesthetics, I created these illustrations. The important part for me is that these are living maps. Most maps show only dead space. There's hardly a living organism or process visible on a typical map. But what if we map organisms and living beings? How can that look like? To create a living map based on real data, we can use a live stream like this one from Vatican Square. If we take this video and transform this perspective as if we were looking from above, and then recognize all the people and show the Kinesphere infringements as they happen, we see something like this living map. Black dots are pedestrians, green is their movement, and purple and yellow shows where the people mostly run into each other's personal space. Do you see the big yellow blob at the foot of the monument? This is where many people were hiding from the sun, so this kind of map can also show the overlooked need of the people, like the need for shade in the Vatican Square. and we can use every webcam in the world, and with this technology transform the live stream into a living map. If we zoom out to a city scale, we can observe the experience in the whole city. I asked 3D artist Andrei Shvetsov to explore how that could look like. This is a browser-based map of Kinesphere infringement per second in the city of Milan. The Kinesphere infringement per second is an index of how often somebody enters your personal space in 1 second. Using the data gathered by the scientists of Sony Computer Science Lab in Rome, we can look up what experience we can expect at different streets at different times of the day. This is real-world data. With this map, you can choose how you go through Milan, depending on whether you want to be among people or if you want to be alone.
All these projects are here to remind us that we are bodies. We are human bodies. We perceive the world as bodies. So maybe it's time for us to stop designing our surroundings for images or for beautiful renderings, and instead start designing them with regard to what our body needs.